Alright, so since we can't meet on campus together today, I've created this video to go through the labor supply lecture that we've been postponing. And since you've been advised to stay at home, you can watch this lovely video in the comfort of your own home and hopefully learn something about labor supply decisions today. Alright, so the labor supply question is really asking how many hours a consumer decides to work. And in particular, the interesting thing about labor supply is it's the first time that we are going to look at a model where instead of consumers demanding something like consumption goods, they're going to make a supply side decision. And we're going to have to very carefully think about the impacts that the supply side decision has on purchasing power of the consumer, and then therefore how it affects their willingness to trade off, what we're going to define later as leisure for consumption. Okay, and so what you'll see in a moment is we're going to have a model where, utility is going to be defined over R and C, where R is going to be called leisure and C will be consumption goods. And the general idea is that, when you're not working, you're consuming this good called leisure, and the opportunity cost of consuming a unit of leisure is actually the lost foregone wages that you would have received in that hour of leisure, for example, that you would have received if you worked. So let's take a look at how we can incorporate this into the very standard framework we've been using since the midterm, where you have a basic model of two goods and the consumer is endowed, with some amount of the two goods. We're going to go ahead and analyze this. All right, so let's first start off with what type of variables we'll be working with. So what we're going to really want to ask is, okay, how much consumption is the consumer going to consume, which is C, and then how many hours of labor will he supply to the market? And the consumer is really going to be a wage taker, okay? He's one of many laborers, standing in line to work at a factory for a set hourly wage, and he doesn't get to choose the wage rate that he receives for his hour of work, not in this model. And any time that he does not spend working, we're going to define as leisure. So if you look down here, okay, R, which is called, I don't know what R stands for, maybe it's R for relaxation, I don't know, is going to be defined as L bar, which is going to be your maximum amount of hours, your time endowment in life, okay, minus L, which is the number of hours that you spend working. So for example, if the number of hours that we're considering is more like 24 hours, then you might have a situation where, how do you do this? Okay, anyways, maybe, L bar is equal to something like 24 hours, and let's say you work, I don't know, 12 hours, since you're Chicago students, then that means that R, which is leisure hours, is equal to 24 minus 12, or 12 hours, okay? Yeah. All right. So you could think about it, R, the units of R being the same units of some maximum time endowments. Another way that you can think of L bar, well, L bar is anyways your time endowment. It's a maximum number of hours that you have available to you. Notice that in the example that I gave with 24 hours, if you're working 12 hours, your leisure time, which is your remaining 12 hours in the day, it actually includes everything else, anything that is not working. So it includes sleeping, It includes eating time. It includes time on the couch or something, watching TV. I don't know, exercising, doing chores, calling your parents, whatever. Okay, it's not always something that's particularly pleasurable. You know, you shouldn't think of leisure in the technical way that we're defining it as economists, as leisure as in sitting on the beach. It's literally anything that you're doing that's not working, okay? So if, for example, we had L bar, you know, equaling 24 hours, your wage rate would have to be on a hour, 24, it would be on like an hourly basis. Yeah, it would be on an hourly basis. So it would be your hourly wage rate. Because it's the W, which is going to be your wage, is going to be multiplied by L, the number of hours that you work. If, on the other hand, L bar were something like 7, because let's say your time endowment is now measured in terms of days, then let's say you work 4.8 days out of 7 days, which is your time endowment, L bar. What did I say, 4.8? Anyways, let's say you were working 4.8 days out of 7 days, which is your time endowment, then you would have something like 2.2 hours of leisure, 2.2 days of leisure out of that time endowment. And since your time endowment is measured in terms of days, which is your unit, then the wage W that you're going to have, which is like going to be your price of leisure, your price of working, that's going to be a daily wage, okay? So notice that this time endowment that you have, the maximum number of hours that you can spend working, or the maximum number of days that you can spend working, the maximum number of weeks you can spend working, however whatever the unit, that time endowment is also going to be the same time endowment that you can have for leisure. Which means if you were to spend 0 hours on leisure, so let's go back to the 24-hour, or let's use 168 hours. I think I gave you guys an example of that in your in-class quiz. So let's say you had 168 hours a week to work, then if you literally did nothing else but working, you're not sleeping, you're not eating, you're doing nothing at all, that 168 hours would be your L bar. But you could also define, suppose I worked 0 hours, then I could spend at maximum 168 hours of leisure. And remember, leisure is just anything that you're doing that's not working. How the hell do I erase this? All right. So at this stage, I would usually ask if anyone has questions, and I'm sure Judah would have a question, but since he's not here, we're going to just move on. Okay, so now, I talked now about consumption, which is your endogenous choice variable labor supply. What we're actually going to do is we're going to, instead of looking at labor supply, which some macro models, a lot of them do actually, we're going to define our utility function in terms of R, which is leisure. But in any case, what are the prices and income that we're looking at? Well, income is just going to be like capital M, okay, just like before. Your wage rate, W, and remember, the wage rate will be in terms of the units that we're measuring, your labor or leisure decisions. And then P is going to be the price of consumption goods. Now, in this simple model where we just have two variables, leisure, R, and consumption, C, we're really considering consumption to be like all types of consumption. So when you think about this price P, when you think about this price P of consumption, it's really the price level in the economy. And I'm stressing this because later on we're going to be able to make a distinction between W, which is your nominal wage rate. What I'm saying here, I'm saying nominal wage rate versus a real wage rate. Okay. Delete that. All right, so we already talked about this. So L bar is your maximum amount of labor supply possible. L bar is also equivalently the maximum amount of leisure that you can have. And so if we multiply your maximum amount of labor supply possible, L bar, by W, the wage rate, this quantity, which is like, I mean, it's a price times quantity, so it looks like an expenditure, but in any case, you know, your expenditure, so to speak, on labor supply, it's not really an expense, it's actually like a, you know, your income, right? That's actually exogenous in the sense that the maximum amount of income that you could possibly make if you're just devote all your hours available, your time endowment towards working, multiply that by your wage, that amount is something that's exogenous. Now, I mean, it's probably unlikely that the optimal choice will end up being at that corner solution, but if you had that possibility, you know, that this kind of upper bound on your earnings is something that's not set by you. It's set by the market, which gives you your wage rate, and whoever gave you your time endowment. Okay. And similarly, you can also define this another variable, C bar, as being M over P. So what's M again? M was your non-labor income here. Ugh. M was your non-labor income here. And if you were to spend all your income on consumption goods, well, M over P is the price. It's kind of like your, you know, y-intercept, right? That's the maximum consumption possible if you didn't work. So that's C bar. And just as we did with labor supply, if you were to spend all your income on consumption goods, you would just get P times C bar. Meaning, P times C bar is the maximum amount of expenditures that you can have on consumption goods given this M income that you have. So we're going to now need to write down a new budget constraint. So the budget constraint is going to have to incorporate this element of time. So first, let me just motivate the budget constraint by focusing on this thing here. This thing. Oh my gosh. This, yeah, okay. Where the hell did that go? Oh, I think it's because I'm on eraser mode. Okay. Oh, great. This is the unedited copy of the video. All right, so let's focus on this thing here. So on the left-hand side, we have a price times quantity, and in particular, we have a price, the price of all consumption goods, multiplied by you know, the quantity of consumption that we're having. That's expenditures, right? That's in fact your total consumer expenditures. Now, your total expenditures on consumption goods cannot exceed, one, the income that you get exogenously from the sky, the same income M that we were working with before, in addition to whatever income you get by working. Because W times L, let's say you work 8 hours, you get a wage rate of 10, that's $80 that you're getting in earnings. And you can add your 80 bucks to, let's say, your $100 of income that you got exogenously. Well, then that's a total of $180. And your total expenditures on consumption goods cannot exceed $180. Let me just write down that example that I gave, make this smaller. So for example, okay, I don't know about all of you, but I find this thing really annoying. Okay. Can I change the color? So if M were, $100, that's your exogenous income. Okay, I want to make this, what if I make this even smaller? Okay, good. And then let's say your wage rate was like, what did I say, $10 per hour, and L was, 8 hours. So that means you work 8 hours out of, let's say, L bar equals 24 hours a day. Then this means that you're making W times L, which is 10 times 8, $80. So your total income is equal to 100, which was the income that you got from the sky. It's your endowment of income, plus your labor earnings, which is 80. So that's $180. Oops, $180. So your total income, now that you've decided to work 8 hours out of the day, is $180. And you can spend that entire $180 on consumption goods, P times C. Okay, so we call this $100, okay, we call that non-labor income, because that's your exogenous income. You got the income through some sort of lump sum transfer. You didn't do anything to get the money, okay? That's the money that came from the sky. It's your M. The $80 in this example is called your labor income. Now, why are we distinguishing between non-labor and labor income while your labor income includes this L, which is an endogenous variable? It's one of your choice variables. So you have a choice over your labor income. You don't have a choice over your non-labor income. And so it's going to be this trade-off between working more and getting a higher L on the right-hand side to increase your income, and consuming less C to reduce your expenditures. So you can think about the right-hand side as being an increase in, shifting your budget constraint out, okay, in the old world. It increases your purchasing power. Whereas the left-hand side is sort of like, okay, if I don't want to work more, then I'm going to have to consume less. It's a reduction on the cost side, okay? This stuff. So that's going to motivate, this is really the key equation that we're going to use to then build and construct a budget constraint from. And well, what's wrong with this budget constraint in the current form? Well, ideally we'd like to be able to write it in our standard form where we have, since we're going to want to look at leisure and consumption, we're going to want to have a budget constraint that kind of has expenditures, so to speak, of consumption and leisure on the left-hand side, and then the price-weighted endowments on the right-hand side. So in order to do this, we need to substitute out things that don't look like that. So in particular, notice that so the goal now is to get everything in terms of R and C, essentially. So M and L are these things which are not R or C. They're not endowments of R, leisure, or C, consumption, and they're also not prices of either consumption or leisure. Sorry, labor. No, I said it right the first time, leisure. All right, so we're going to substitute out these things. And the substitutions that we're going to make are the following. Well, I already told you that M, which is your nominal income, your exogenous income, is equal to P times C bar. That was, oops. That was up here. Oh my gosh. That was up here. Okay. We defined C bar, we defined it as being the maximum consumption possible if you didn't work any hours. We're going to make that substitution in here. There we go. And we're also going to substitute in the fact that L, which is your labor supply, is just equal to this differential between your maximum leisure time available and the actual number of hours of leisure that you spend. So plugging that into our budget constraint here, well, okay, so instead of M, we have this P times C bar, and instead of WL, we're going to substitute out L and replace it with R bar minus R. And then we're going to, simplify, and you're just going to get this thing here. All right. So notice it's now in our basic framework in the sense that we have a price times quantity of our two goods. C, which is consumption, R is leisure. P is the price of consumption, W is the price of leisure. And then on the right-hand side, we have our quote-unquote endowments, right? C bar is like your maximum consumption available, and that's governed by your income, your exogenous income, your non-labor income. And then R bar is going to be your endowment of leisure in the sense that this is your maximum leisure time available. And these endowments, I'm saying this in quotes, they're multiplied by the prices of the two goods. So this budget constraint, these two are identical. This is what we call the full income budget constraint. This full part is taking into consideration your time endowment, or this labor choice. Okay? So, all right, good. I have a good note here. So just to reemphasize, the wage rate is not only the price that you receive for your labor, it's also equivalently the price of leisure. So again, if you decide to, spend an additional hour watching TV or an additional hour sleeping or additional hour eating, anything that you're doing that's not working, what you're foregoing is the wage that you would have earned in the market had you worked that hour. In other words, any additional hour that you spend on leisure, okay, R is going to reduce the labor hours that you spend in the market, and that's your opportunity cost of leisure. Spend an extra hour of leisure, you lose your $8 in the market. So this is one way, and we'll talk about it a little bit more when we do the Slutsky equation. It's one way to talk about different labor supply decisions of people that have different hourly wages. So if you look at the investment bankers are actually not really a good example at the low level because your hourly wage, in fact, is quite low. But let's say, and some people have this hourly wage. Let's say your hourly wage is $3,000 an hour. That extra hour that you're spending, sleeping or watching TV or whatever, is literally costing you $3,000 because you could have earned $3,000 in the marketplace had you just worked instead of consuming leisure. So if you have a high hourly wage, you might see people who are quote unquote rich, and rich not because they're wealthy, but because they have high earnings, working more hours because of this opportunity cost of consuming leisure. and compare that to someone who earns like the minimum wage, well, whether or not, I don't know what the minimum wage is now, like almost $10 or something, I don't know. Let's say the minimum wage was $10 or $8, I don't, I'm not really sure. Let's say it's $10. If they can work, earn $10 working at Walmart for 1 hour, I mean, losing $10 for an additional hour of leisure, I mean, that trade-off is not so steep. And so you might see people who earn less actually working less as well. So this trade-off, again, between labor supply and leisure is what governs this, this opportunity cost of consuming leisure. It's a foregone wage that you would have gotten had you worked in the market. Okay, so now let's set up the problem. I love setting up problems. So here we go. So as I mentioned before, the labor supply problem, in the way that we're going to study it today, is going to have two variables: leisure, which is represented by R, and C, consumption. So what does the consumer take as given? Okay, so the consumer is going to take as given his time endowment, R bar, which is, again, the maximum number of hours he can spend on leisure. And that's defined as being if he were to spend 0 hours on labor, working in the market, he would get his R bar. Income M, that's the exogenous non-labor income he just received at the start of this problem. And then the prices. In this case, price P is really, it's like the price level of all consumption goods. Wage W is really a nominal wage that he's getting in the marketplace for his hour or unit of labor supply. Okay? So this R bar and M are really kind of taking endowments and prices as given. Okay, but we can kind of separate this out a little bit more. Time endowment R bar is endowment of income M, and then the price P and wage W is given. But this sentence here is really just taking endowments and prices as given, as we have been doing in the models post midterm. Okay, so now. So what's the problem? Okay, taking his endowments and prices given, he's going to maximize choosing leisure and consumption. The objective is to maximize his utility function over leisure and consumptions, subject to his full income budget constraint. Now, what I showed you above here, all this stuff, was just a derivation of the full income budget constraint. Typically, in most applications, you just kind of like memorize this thing, or you kind of intuitively start with something like this, the beginning that we did, this beginning equation, and kind of build your your budget constraint based on the utility function that's given to you. But for our purposes, you just, you don't need to really memorize this derivation. I hope it makes intuitive sense for you. We're just going to work with a full income budget constraint directly. Does that make sense? All right, everyone seems to be following. All right, so you're going to maximize your utility over leisure and consumption, choosing your, hours of leisure and quantity of consumption goods, subject to your full income budget constraint. And without even, now I'm just kind of taking first order conditions here, okay, without setting up the Lagrangian, but I think you guys can do it. Once you start doing macro, no one's going to set up the Lagrangian, they're just going to kind of take first order conditions in this way. Anyways, so just as before, you're going to differentiate with respect to R. You get your marginal utility of leisure. Here you go. And what's the marginal utility of leisure? That's the additional increment to utility that you obtain from having one additional unit of leisure, holding consumption constant. Okay, well that has to equal lambda, which is our Lagrange multiplier, times the price of leisure, which is W, our wage rate. And then, if you take the first order condition with respect to consumption, again, you get the marginal utility of consumption, which has to equal lambda, our Lagrange multiplier, times P, the price of consumption. And then when you take the first order condition with respect to lambda, which is our Lagrange multiplier on this Lagrangian, which I didn't write down, you just get back, your constraint, which is our full income budget constraint. Undo. Okay. And so, like we've been doing often, you can just take the ratio of these first two first order conditions to obtain our tangency condition for an interior solution here. So what does this tangency condition say? Well, it says that on the left-hand side, what is this? Look at it. It's a ratio of marginal utilities, so that's your MRS. It's your marginal rate of substitution. Now, how do you interpret this MRS for this particular model? Well, notice that R here is our x-axis good and C is our y-axis good. You can see that in this picture here. Okay, R is our x-axis good, C is your y-axis good. So your MRS is it's the slope of your indifference curve. Okay, so it's if I wanted to increase leisure by a little bit, just here, the smaller, let me try that again. So focus on the slope, okay? So if I wanted to increase leisure by a little bit, because this is leisure, how much consumption do I need to give up? Okay? How much consumption do I need to give up in order to get a little bit more leisure and remain indifferent? That's your MRS. So on the left-hand side here, your willingness to trade off consumption to get a little bit more leisure, okay, at the optimum needs to be equal to your real wage rate. Okay, real wage rate. Well, what's your real wage rate? Your real wage rate is equal to your nominal wage rate divided by the price level. This is W over P is your real wage rate. Here, W over P. You're going to see this like over and over and over again in macro. And typically in macro, what you're going to actually see is that you're going to have W, which is your nominal wage rate. Okay, W is going to be your nominal. Oh, that's awful. Can I type on this thing? So capital W is going to be your nominal wage rate, and then little w will end up being your real wage rate. And so when you take your nominal wage rate, you divide it by the price level of all consumption goods, you're going to get a real wage rate. And why are we saying real wage rate? It's sort of real implies that it's the wage rate that you get that says something about your purchasing power. Okay. And the idea is, suppose there's inflation so that the price level were to go up by 1%. Well, actually, aside from during the financial crisis, typically we saw inflation rates of something like 3%. So let's say the price of all goods that you could possibly purchase go up by 3%. So this denominator here goes up by 3%. Well, when the price of all goods that you can possibly purchase go up by 3%, suppose your boss says, okay, well, we need to increase your wage to keep up with the cost of living. So they increase your wage also by 3%. Well, your purchasing power hasn't changed because the 3% is going to cancel out on the top and the bottom, and your real wage is going to stay the same. Okay? So that's why we consider, so the other example is to say, okay, suppose the price level doesn't change, but you get a raise. Then your purchasing power has increased. And that's a real increase in your wage, okay? So your real wage is going to go up. Your real wage can go down, for example, if there was inflation, but your boss doesn't say, oh, we're going to, increase your wages to keep up with cost of living, and you just have the same wage. Well, you're going to be you're going to be able to purchase less of everything. All right. Okay, so I hope all of you can interpret this key first order condition. So this first order condition here, together with the budget constraint, the full income budget constraint, because remember we have feasibility, which is your feasibility, and then your tangency condition, right? So here we go, here's the picture. Feasibility is represented by everything that's in this box. I'm going to explain this kink in just a second. And the tangency condition is here. At the optimum, it needs to be on the budget constraint and at this tangency. That's for an interior solution. If your optimum ends up being here at this kink, that's going to be called a corner solution. Watch out. All right. So let me just take a step back and explain this graph. So just as before, remember we have two goods, R, which is leisure, and C, which is consumption. And R is going to be plotted on the x-axis, C, y-axis. Now what's going on here? Well, notice that since we have this time endowment, which affects one of our choice variables, this L bar, which is equivalent, by the way, to R bar, okay? You can't consume any more leisure, R, than L bar. So there's a sense in which, this time constraint sort of puts in this like ration, okay, on how much leisure you can consume. It puts an upper bound. You can't, if there's only 24 hours to a day, you can't consume 30 hours of leisure. You're restricted to only be able to consume at most 24 hours. Or if you're talking about weekly stuff, you're constrained to work consume leisure 168 hours of leisure a week, and you're literally cannot consume 200 hours of leisure a week because that would exceed your time endowment. So why is there this kink? Why doesn't, I know you guys would ask me this, well, Professor, why doesn't the budget constraint look like that? Why doesn't it intersect, what is this? The x-axis at L bar. Okay, I think you guys are convinced that this L bar is, a legitimate maximum here in terms of the number of leisure hours that you can have. So why do you have this, why are you able to consume this amount? Well, that's coming from your consumption endowment. Well, technically, it's coming from your M, your exogenous income, which we divided by P. Okay. So here, your non-labor income can be converted into consumption. So even if you didn't work at all, we're looking at leisure. So even if you didn't work at all, in which case you'd be consuming the maximum amount of leisure time, well, you can still consume, which is on the y-axis, you can still consume this amount of consumption, okay, C bar, because remember that your budget constraint here had this you had like a labor and non-labor component. So your expenditures, even if you decided not to work at all, you can still consume P times C, PC equals M, even if L were 0. If L equaling 0 implies that you're consuming leisure R equal to L bar. So this is exactly C bar here. If you didn't work at all, you'd be able to consume at most C bar. That's why all of these bundles here are feasible if you were to not work. That's why you have this kink. Because first, it's like you got, because you have this non-labor income, which enables you to at least get C bar without working at all. All of these bundles are feasible, and then now the price ratio between leisure and consumption comes into play. This slope, once you start at this kink point, which is the maximum amount of consumption you can and leisure you can have by not working at all. So if you start at this kink point, then you need to now apply the opportunity cost, where you're for each. It's getting messy. So if you start here, if I were to give up 1 hour of leisure and I were to work an additional hour here, I can increase my consumption. And I can continue with that. Suppose I were to decrease my leisure, which means I'm increasing my labor hours. Okay, that enables me to have a little bit more. Why is my consumption increasing every single time I, decrease leisure and instead work a little bit more? Well, that's coming from my labor income. Each time I decide to work more and consequently spend less time on leisure, that pushes this whole right-hand side up. My total purchasing power goes up, and therefore I'm able to spend more. And that's why C is able to go up at from a feasibility perspective, is able to increase each time I spend more time on labor and less time on leisure. So because of this fact that total time is equal to, leisure plus working, if I pick some arbitrary point here, this amount here is going to be leisure, because it's from 0 to, 5 hours or something. And then this other remaining part, which is the distance between my time endowment and my leisure decision, that distance is equal to my labor hours. So at the optimum, which is this, I've drawn a picture here where the optimal choice happened to be an interior solution. This distance from the origin 0 to R star, okay, R star, R star, I think you guys get the idea. Okay, R star, from 0 to R star, that's my leisure hours. And then the difference, which is this distance here, is L bar minus R star. That's the distance. It's also difference. That's actually equal to L star. That's kind of implicitly already defining my labor supply decision. the number of hours that I choose to work, L star, is equivalent to all the hours left over remaining if I just choose my optimal leisure hours. And that's coming from my time constraint. That the total time available, where is it? Here. Has to equal my labor plus leisure hours. All right. I think you guys will have to replicate a picture that looks a little bit like this for your in-class quiz on Wednesday. All right, so now let's talk a little bit about the Slutsky decomposition. Well, before we go into the math, I mean, you can kind of imagine what's going to happen, right? Suppose one of our prices change. What we typically are really interested in is suppose your wage rate changes, okay? Since we are in the endowment model, what is it going to look like if the wage rate, W, were to increase? We know it's going to change the slope of the budget constraint. And so the question is it going to be steeper or flatter? Well, an increase to W is going to make the slope a bigger number in magnitude, so it's going to make the slope steeper than the current. Now the thing is, if we're dealing with a model where you have an endowment, we know that when there's a price change, the new budget line needs to go through the endowment. Oh boy, that does not look like a line. This Apple trackpad is not the best for doing these types of things. Okay, so that's like my new budget constraint. All right, that's just my new budget constraint if the wage rate were to go up. Again, why do I have this thing? Well, just because my wage rate went up doesn't mean that it changed, holding the price of consumption constant. It doesn't change the maximum amount of consumption that I'm able to consume, nor does it change my time endowment. So I still have this kink, and the only thing that's changing now is the slope. Well, notice that now, compared to before, my purchasing power has increased because I've held price P, the price level, constant. So not only do I experience a change in my opportunity cost of consuming leisure over consumption, but I also get an income effect. I can at every level of leisure, I can consume more consumption. So what we'd like to be able to do is decompose this effect using the Slutsky equation. So comparative statics. So what we can do now is totally differentiate R. So now R here, this function, right? That's just our Marshallian demand for leisure. It's a function of the price of the x-axis good, which is our wage, the price of the y-axis good, which is the price level, the price of all consumption goods. And then here is our endowment. It's like our income coming from our endowments. So just like before in the endowment model, the buying and selling model, we're going to, we can just totally differentiate this thing using the chain rule, because if we want to look at a situation where the wage rate were to increase, we need to take into consideration the direct effect it has on leisure as well as the indirect effect it has that's coming from the increase in income. So here we go. I can differentiate with respect to the first argument. and then income here. And I'm picking up this R bar because that's coming from the chain rule here. All right. Well, I think you guys know how to do this from the in-class quiz a couple weeks ago. When you totally differentiate using Slutsky's equations in the endowment model, what you can, we're going to what we just did is we totally differentiated the endowment model, and now we're going to substitute in the original Slutsky's equation here. And that's where we get this Hicksian demand, which is our pure substitution effect, and then we pick up this additional term here. So the final product, okay, is this thing. So we get a substitution effect and the income effect. Now, mechanically, this is exactly the same as what you've seen. I mean, basically, I think you guys did this in your quiz, right? So what's interesting in this model is how you can interpret this. So how do you interpret the substitution effect? Remember, we're asking how the consumer's optimal leisure decisions, okay, which then implicit, by choosing an optimal leisure decision, you're actually also pinning down his optimal labor supply decision because of this time constraint here, okay? So what happens to the labor leisure decision when the wage rate goes up? All right, well, first, there's a substitution effect. When your wage rate increases, what happens? It's going to change that slope on the budget constraint, or the opportunity cost of consuming more leisure in light of giving up consumption for leisure. Well, that's going to be your substitution effect. Now, since your wage went up, the price of leisure has increased. So this is like, compare the guy that's making, if you're making $200 an hour and your wage rate goes up to $210 an hour, the opportunity cost of consuming additional unit of leisure has gone up. That's your substitution effect. And we know the sign's going to be positive by the law of demand. Good. Now the income effect. So the income effect is coming from the fact that, look, the more you're getting paid for working, the more money you're making. So you have this income effect, your purchasing power goes up, and I mean, probably can guess where I'm going with this. Whether or not this income effect is positive or negative is going to depend on whether or not leisure is normal or inferior. So if leisure is a normal good, which means the richer you are, or rather the higher your income is, the more leisure you consume, that's going to reinforce the substitution effect. And it's going to give a positive income effect, so when your wage rate goes up, you're going to consume more leisure. If leisure is an inferior good, it can go in either direction. Either your income effect can be positive or negative, and depending on the magnitude of the income effect relative to the substitution effect, it's going to determine whether or not overall leisure goes up or down. But notice that leisure going up or down, if leisure goes up, that means that labor supply goes down. In the other case, if leisure goes down, that means that labor supply has gone up. That's because your total time, because your total time endowment is equal to the sum L plus R. All right, so let's do each case separately. So again, if leisure is a normal good, then unambiguously, oh my gosh, is there an error? either in what I just said or my notes. Let's see, if leisure is a normal good, this thing is positive. R minus R is always positive. Oh my gosh, ignore what I just said like 5 minutes ago. I think I verbally said the wrong thing. This is correct here. What's written on my lecture notes is correct. If leisure is a normal good, then that means that when income goes up, I consume more leisure. In other words, the sign of this derivative is positive. So taking our Slutsky decomposition, we can sign each term one by one. So first, we know by law of demand, the substitution effect is always negative. And the income effect, well, the income effect is going to be positive. Why? Because if leisure is a normal good, this derivative here is positive. And R bar minus R, by the time constraint, is always going to be positive or 0. Probably positive. So whether or not the income effect, which is, this whole thing, is bigger or smaller than the substitution effect, is going to determine the overall sign of this derivative. Yeah, that's right. So when leisure is a normal good, the demand for leisure has an ambiguous sign. Okay, it's ambiguous. So it's really going to depend on whether or not the income effect or substitution effect is dominating, because the income effect and substitution effect have different signs. And what's going on here is, the more I'm making, the less I want to work. That's the income effect. But the substitution effect is saying, look, each hour I'm not working is actually costing me more in terms of my foregone wages, so it's actually pushing me to work more. That's the substitution effect. Which of these two effects dominates will determine the overall sign of whether or not leisure goes up, and therefore whether or not labor supply goes down. Okay? And in the other case, where leisure is an inferior good, well, then there is an unambiguous sign. The more I work, if my income goes up, and I always want to consume less leisure, then that's going to reinforce. That's going to give me an income effect, which is negative. It's going to reinforce a negative substitution effect. So the overall effect will always be negative. So if leisure is an inferior good, when your wages go up, you're always going to consume less leisure. When your leisure goes down, that means that your labor supply goes up. Again, if your leisure goes down, that means your labor supply goes up. So when you consume less leisure, you work more. All right, so okay, this is a good, thankfully I don't have to draw this graph on the board. All right, so suppose leisure is a normal good, and let's say I plot the case where there ends up being an increase in leisure, which means that this total sign is positive. Well, in the original case, I was here, in the green line, okay? And let's say my wage rate goes up. That increased my slope, but remember it pivots on the endowment, and I have to keep this time constraint, L bar, or R bar, let's call it. Okay, so that's why the new budget constraint still has this kink. Still has the kink. And now we want to decompose the change that's coming from the original to the final. And we'd like to decompose this change between an income effect and a substitution effect. So how do we do that? Well, first, we need to hold purchasing power constant and ask, what would the consumer have done had we held purchasing power constant? Here's my purchasing power. if I hold that fixed and keep the slope the same as the final budget constraint, okay, I can ask where would the consumer have purchased had that been the price change between this original and this new one. Well, if he was consuming somewhere like here, we know it needs to be to the left of the original. That's really messy. We know it needs to be to the left of the original decision, and that's just coming from the substitution that's coming from the law of demand. We know it needs to be to the left. So suppose it was just here, okay? Then this change is your substitution effect. Now, I'm not going to decompose the endowment income effect and whatever, okay? But the total income effect is now looking at this intermediary bundle, okay, to the final bundle. And in this case, the one that I drew, the income effect overwhelmed or dominated the substitution effect, which was going the opposite direction, dominated and was able to push the consumer to consume at a leisure level R prime, let's say, that was higher than the original R star. So in this case, okay, when the wage rate went up, this guy consumed more leisure. So if he's consuming more leisure, what does that imply about how many hours he's working? Well, if he's consuming more leisure, he's supplying less labor. And so what we can talk about is this thing called a backwards bending labor supply. Well, if we just plot quantity of labor supplied against wage, it could be that at low levels of wages, if you were to increase your wage, that people would say, okay, I'm going to supply more labor. Give me a raise, yeah, I'm going to work a few more hours. And this might continue for a while, okay? And it's generally, like empirically, when we look at data, we estimate this stuff, that's generally what we see. But, there might be this L max, which is different from your L bar, which is like way out here. Your L bar is way out here, but L max there might be like this point at which, the worker just says, look, it doesn't matter how much more money you pay me, I'm just not going to work more than 100 hours a week. And so even if you're offered a higher wage, you may actually start working more. Working less. Why would you work less? Why don't you just keep working at this L max? Well, that's coming from the income effect. If you keep paying the guy more, and he's going to realize that he can consume the same amount of consumption goods by working less hours, right? If you're getting paid $20 an hour versus $100 an hour, well, it might have cost you 5 hours of labor in order to get $100 worth of labor income, whereas if you're being paid $100 an hour, you only need to work 1 hour to get that $100. And that's where you're getting this backwards bending labor supply curve. Something that you'll study more later in macro, hopefully. Okay, so that's why we call this backwards bending labor supply. And so one implication of this backwards bending labor supply is that it's possible to see at the optimum a consumer who's willing to work the same hours of labor at two different wages, at a low wage and a high wage. That's the implication of any situation where you have like something that's backwards bending. I just wanted to show that to you. You won't be tested on it, but it's something that's good to see, just in the early stages of your economic careers, because you'll see it again. All right, so that's it for this lecture. Briefly, let me just kind of go through the nope. Pretty sure I had it. Yeah. So on the online quiz that's due tomorrow, well, whenever you're watching this, 5 p.m. Tuesday. First question. Okay, so the first few questions, up until question 5, deal with intertemporal choice and investment model that we looked at last week on Monday. And then the remaining questions are looking at labor and leisure. So what is the price of labor and leisure? Okay, we definitely covered that over the lecture. And if you're not sure, just look at your budget constraint. Just look at the budget constraint. Here, your full income budget constraint. Identify the normal structure, you have endowments on the right-hand side, and just ask yourself, what is the price of leisure here? Okay. And where did I get this price? All right. For question 6, why is there a kink in the leisure consumption budget constraint? Now there's two options here, because the 40-hour work week rations leisure, or because the consumer faces a time constraint. How would you represent, a 40-hour work week? In this basic model, we don't have a 40-hour work week. It's 40-hour work week. It's possible that the consumer might optimally choose 40 hours in the work week, but the budget constraint that we're looking at is a work week of 168 hours, in the sense that this L bar is your maximum amount of hours worked, or equivalently the maximum amount of leisure that you can have for the week. It has nothing to do with any sort of legal constraint. Now, it's possible, of course, that we can have a new, we could create a new model where instead of having this time endowment, you have this, maximum work week situation, but that's actually becomes a more complicated model, which I don't want to get into. All right. Question 7, suppose leisure is a normal good and the wage rate increases, then whether or not more leisure is consumed is ambiguous. Okay, hopefully you listened to the later part of my explanation, but look, the answer is definitely in the leisure, in the lecture notes here, so just read that. Oh, question 8. Suppose leisure is an inferior good, blah, blah, blah. Look, it's here. It's on the other side of the lecture notes. So I think you guys can get it. And then what I have you do in the in-class quiz on Wednesday is to kind of solve through, basic Cobb-Douglas example of a labor supply model, and have you, you'll have to draw a picture that looks something like this. So the in-class quiz is definitely posted online already on the website. You can take a look at it, and we're going to proceed with having the in-class quiz on Wednesday as scheduled. Okay, so just to summarize, on Wednesday in class, we're going to do a final exam review. It's going to be a lecture format where I'm going to lecture and basically summarize all the models that we've covered in the second half of the course. I'm going to give you what's hopefully going to be a pretty directed study guide for the final exam, and then we'll take the quiz at the end of class in case you have any questions, and then I'm welcome. I'm happy to entertain any additional questions you have at the end of class. All right. Well, thanks for listening. Sorry I wasn't able to be either with you to do this on the blackboard, but hopefully this is a sufficient substitute. All right. I'll see you guys on Wednesday.